Morning, sir.
Good morning, Dr. Sterling. Good morning.
A very pleasant morning to all present here. Thank you for being with us today on the fourth episode of Rink Product Showcase. Rink is Research Innovation Network Kerala, a project by Kerala Startup Mission to translate research products into successful commercial ventures. Rink is formed to support technology products in the research labs to be commercialized and can be open to industry and startups. The demo day is designed as a series of product showcases from selected research institutions. Please block your calendars on last Thursdays of every month. We'll have product showcases blocked on that particular day of every month. Today, we have the Ring Demo Day hosted by Center for Materials for Electronics Technology, Cmet, and also supported by TiE Kerala, our industry partner. Cmet is a unique institute dedicated to the development of viable technologies in the area of electronic materials. It is registered as a scientific society in March 1990 under the Ministry of Electronics and Information Technology, Government of India, and has 3 dedicated laboratories located at Pune, Hyderabad, and Thrissur, with Pune as its headquarters. The thrust area of Cmet Thrissur are sensors and actuators, microwave materials and components, plasmonic materials and devices, nanomaterials, and materials and components for energy storage, including supercapacitors. We extend a very warm welcome to all the dignitaries from Cmet, the speakers, and the participants for the day. We are starting our day with an opening remarks and the opportunities in Cmet by Dr. N. Raghu, Director of Center for Materials and Electronics Technology, followed by product demo by the innovators. A very few words about him. Sir took his PhD from IIC Bangalore in the area of electronic ceramic materials and did his postdoctoral research at Penn State University, US. His group developed a variety of piezo actuators and materials for electronic packaging applications for strategic sectors. He is a member of the Materials Research Society of India and has served as a member of the Naval Research Board Materials. Without taking any more of your time, I would like to invite Sir Dr. N. Raghu, Director of Cmet, for the opening remarks and to talk about the Cmet opportunities. Sir, please.
Thank you so much, Salini Madam. A very good morning to every one of you. I hope I'm audible.
Yes, sir.
Thank you. Once again, warm welcome from my side and on behalf of the Cmet fraternity to all participants, especially all the entrepreneurs, industrialists, startups who are eager to and ready to form linkage with Cmet. Thank you so much. Without you, this platform or this function has no meaning. I take this opportunity also to welcome my colleagues who are eager to showcase their hard work over the years. A big salute to the Rink team led by Dr. Riaz, Ms. Salini, and their entire team for giving us such a wonderful platform to showcase some of our products. Dr. Salini has already given you a brief introduction about Cmet, so I'm not going again back into that. So this is a very first introductory meeting where we are trying to, first of all, know each other. What are our strengths? What are our limitations? How we can shake hands together is the entire purpose of this particular meeting. So keeping this in mind, I would like to introduce Cmet once again. Many of you may be aware what is Cmet, may not be aware what is Cmet. Whenever anybody asks me from which institution you are, I always confine myself to Center for Materials. The moment I say it is Center for Materials for Electronic Technology, then people think that we are from electronic background. No, we are from materials background. We are from material science background. most of us, most of the scientists here are with physics and chemistry background who have turned ourselves into a material scientist. So this is our brief introduction of our people. And as Ms. Salini was pointing out, we have 3 centers, Pune, Hyderabad, and Thrissur. Each of us, see, if you remember the stories that happened in the early 90s, I think it was Dr. Sam Petroda period, like you must have heard certain institutions' names. For example, CDAC, CDOT at that point, CDAC, CDOT, Cmet, like that, a variety of autonomous institutions were started. In fact, they are all our sister institutions. We all come under like Samir, NILAT, like that. We have a variety of institutions. We all come under the same ministry called Ministry of Electronics and Information Technology of the Government of India. And this is an research institution. Cmet is meant for development of electronic materials. Having said that, let me give a brief introduction about so that the further process becomes more meaningful. Any electronic based system, the base, the fundamental thing is absolutely materials. It can be a semiconductor, it can be a metal, it can be a polymer, it can be a ceramic, but without materials, you cannot make any components. Without components, you cannot think of coming out with devices and the PCB and other boards. And once those things come into picture, then only the system is going to come. Whatever be your electronic product, this is how the whole chain goes. So the fundamental basic thing is materials. That is where we are concentrating. It's known as the electronic materials. Of the 3 laboratories, I would like to, because anyway, Cmet Thrissur products, some of them will be projected here. So I would take a little more time to explain you what other 2 labs are doing, as well as what are the other possibilities that can happen in Cmet Thrissur itself, though they are not being discussed right now in this meeting. Probably we'll have the second round where we can think about. As for the Cmet Hyderabad is concerned, they concentrate on certain trust areas such as high purity metals. When they mean, what they mean by high purity metals is purity of the order of 6N, 7N. What I mean is that 99.9999, if you want, you can put one more 9. So that kind of purity metals, alloys, they also work on semiconductors. So most of the metallurgy oriented, they have, and the difference between Cmet and some of the labs is that not only we develop the basic material at the laboratory level first, once we are confident, we take it to the pilot level. So demonstration of technology at the pilot level so that the Indian industries or any startup who wish to come out with indigenous product get an opportunity on the technology platform. And that is where this whole game, and that is the purpose of Cmet. Having mentioned the trust areas of Hyderabad, if you can actually go to into our website where all the details and what are all the products that are there, everything is being mentioned. I also would like to mention that though most of our products, we are doing it for materials development and the components and the devices, what we are making are material based, and these are all done for strategic sector, for strategic applications like defense, atomic energy, or space. There are variety of products and technologies that has evolved over the period. We are relatively young organization. Our age is still, it started in 1990s, what Madam has also told you. So roughly around 30 years, 31 years of experience for us in this field. And so we have taken into account what are all the other industries can benefit, where we can have societal importance, societal relevance. So these are all the aspects we have looked at, and a variety of technologies have come, and some of them we will be displaying it today. And coming back, the one such major work that is being carried out at Hyderabad, first I would like to highlight, it is on e-waste recycling. And e-waste recycling has been done at our lab, not only at the lab scale, we have the complete pilot scale, and we also have with us the demonstration capability of extracting valuable metals from PCBs, spent PCBs, to the tune of 100 kg per batch. To that extent, you will be able to demonstrate. And this is Center of Excellence has been started in e-waste. And in fact, last month, along with MSME at Thrissur, the entire meeting was there on this issue, so that any entrepreneur interested can approach us. And I'm sure that all these Center of Excellences, we have many like that at Pune and here also. And these Center of Excellences are there mainly to welcome industries, entrepreneurs, startups, so that the journey has to be right from A and all the way up to the production. So we stand by that. And that is one particular area I just mentioned because it has got a lot of societal importance, and you know the importance of it. And another thing at Hyderabad I would like to highlight is that they have an excellent characterization facility, which is also very essential. Supposing you want to come out with any electronic product and you are interested to, let us say, export it to Europe, there are certain things like you have to do certain compliances. It's called restriction of hazardous substances. So how much is the content of lead, cadmium, like that? There are varieties of 6 elements are there. So one has to understand. So for all these things, they have that is the one and only government-owned NABL accredited lab for ROHS. So these are the two important things I thought I'll just highlight. There are a variety of other technologies that are available from them. Kindly look at our site. When it comes to Pune, they concentrate on variety of high purity chemicals. That is one major area. And they move on to a variety of technologies for batteries. So you all know the importance of batteries. So that is very essential, be it lithium-ion battery or all the other associated batteries technologies. Everything is being looked at. There is a center of excellence there, and all the materials, including up to packaging and making the battery and demonstrating it is for a two-wheeler or for electronic mobility. That kind of work is happening at Pune. The same, they have a pilot level demonstration of one of the electronic packaging application, which is well known and at Pune. Coming to the major thrust area of Cmet Thrissur, our thrust area will fall under the category called electronic materials, no doubt. Within the electronic materials, we come under an area called electronic ceramic materials. There are a variety of ceramic materials that can show specific properties needed for electronic applications. So electronic ceramic materials and polymer ceramic composites are our major thrust areas. And as Salini Madam was mentioning, we have a variety of program. First, I will mention about the sensor activity and the kind of thermal sensors that has been developed and the kind of variety of byproducts that has come out and the various technologies Dr. Seema is going to present today to all of you. Not only that, very recently, by shaking hands with the Digital University, which is known as, previously it was known as IIT-MK at Trivandrum, recently the same team, Dr. Seema and Digital University and all others have joined hands to come out with IoT-based sensors. So a variety of sensors, be it proximity sensor or touch screen sensor, whatever. So a variety of sensors are being planned under that scheme. It has just been initiated. It is a 5-year program. A major facility will come, and one of the important points in that is that we want to shake hands with startups, shake hands with industries. So if you have any specific IoT-based sensor requirements, kindly contact us. So this is another major thing. And another major thrust area for us is piezo sensors and actuators. Okay. Dr. Kumar, Dr. Karthik, they are all working on this area. And piezo sensors and actuators for underwater application, as well as, for example, so you want to know this, because all the right from the material to the component to the device, it is being developed here, and all these have been tested, for example, at a laboratory called National Physical and Oceanographic Laboratory, right at Cochin. They are one of the defense laboratories. What are they doing? They will send acoustic signal underwater in the ocean to understand whether there is any submarine. For that, there should be a transmitting device which sends the acoustic wave, and there should be a receiver to receive back the signal that's coming from the target. So those kind of materials and technologies are available. That is, Dr. Kumar and their team are working on that particular aspect. And I also wish to mention that another major program has just, we have got the sanction, and the money is also probably reached 1 or 2 days back. So there, what we are looking for is same piezo sensor based. Can we think in terms of developing? Already there was a major program of from NILET, which is another autonomous society like us under the same ministry at Kozhikode. They are in the process of making ultrasound, indigenous ultrasound machine. So there, the main important thing is the heart is actually the piezo sensor. So that is where, again, Dr. Kumar and the entire team have joined hands to see how best we can develop so that it becomes a true indigenous technology for the Indian industries. Like that, we have with us an youngster who is working on flexible wearable sensors for various biomedical applications, Dr. Larul Kashmir and their team. So like that, we have major plans, and which is still at the stage of initiation, where central government we are planning to is ready, and state government is ready to support, along with industries, graphene and other 2D based materials for sensors, and a variety of electronic and optoelectronic applications are being planned, again by Dr. Seema and Dr. Radhika. There are a variety of team members to take care of these kind of activities. And anyway, when it comes to the same sensors, like for example, Dr. Poti, he has been concentrating mainly on plasmonic based materials, and he has come out with cheaper, cost-effective materials and components and devices that can detect, for example, gas sensing, like, for example, ammonia, hydrogen. These are usable and use and throw kind of sensors is what he's coming out with. And again, he's in collaboration with RGCB, he is coming out with biosensors. So these are all probably, I think Dr. Koti will be giving full details of these kind of technologies as well. So sensor and actuator is one major area in which many of our scientists are absolutely involved. And the next major area for us is energy storage. When it comes to electrical vehicles or power electronics, whatever the applications, battery alone may not be suffice, because you need to have what is the energy density consideration as well as power density consideration. A combination of this is always better. So if you have a combination of battery on one side plus the supercapacitor on the other side, it helps for many of the applications. Hence, we have big pilot plant facility for the production of aerogel. Aerogel means one of the world's lightest known material to mankind. So that kind of light materials are being made here, and Dr. Stanley will be giving one of the applications of that aerogel based supercapacitor application, and Dr. Seema will be presenting on the graphene based supercapacitor application. Another major area of activity, one of our thrust area is microwave materials. These were embargo item. It started as a very small project from one of the strategic sector, VSC Trivandrum. Now we have the complete pilot plant facility for that. So if you want to come out with any microwave based device or component, you want to let us say you want to make a microwave oscillator, filter, or an antenna, you have to have something called base material is the flexible substrate, which is nothing but like your PCB or ordinary electronics. The difference is that this has to work at microwave frequency. That means it has to have properties of all the requirements needed at gigahertz range. So these kind of materials have been developed. Not only it has developed, it has been demonstrated at pilot level. And we are happy to say that our team is, Dr. Panmand is taking care of this major activity here. And the entire activity, which was initiated by Dr. Ratish, is fully taken care by Dr. Panmand. And I'm happy to say that we are supplying it to all our strategic requirements, and this technology is also transferred and these details are there. And if anybody is interested to make a patch antenna or is interested to make it, convert these microwave substrates that we have made in the form of, let us say, a NAVIC antenna, those kind of activities also are going on in collaboration with the Cmet Hyderabad, who is which is being headed by Dr. Ratish, who was very much available here with us. So a variety of products, sensors, actuators, energy storage devices, microwave materials, plasmonic materials, nanomaterials. These are all our areas and variety of products we are looking at it. And of course, we are also working on microwave-based absorbers. This is being taken care by Dr. Arul Kashmir. So there are a variety of technologies are available. 3 of our scientists are presenting today. The rest of the people probably will come in the next round. So fine, all these technologies are available. I have been attending thanks to Rink platform and Dr. Riaz and Saldi madam. Major questions that repeatedly come in every meeting is that, fine, you have all these technologies. How are we going to get it? What are the benefits? So I'll spend a few minutes on that. These kind of technologies, once it's developed, we advertised in our newspapers as well as we put it in our website. If you kindly go to our website, www.cmet.gov.in, you can find all information, what are the technologies that has been developed at different laboratories, and what is its technology readiness level, and all those informations are available. Kindly contact. And our all this technology transfer related matters are dealt by our headquarters at Pune. Program coordinator is there, Dr. Rao. So you can contact us or directly Pune. Whatever way, we'll be happy to shake hands with any one of you. So many a times we ask for expression of interest. So we understand, okay, so-and-so industry or startup is having interest in these technologies which are already developed, then an expert committee will be formed. They will look into if this technology is transferred to you, will you be able to technically competent enough to take it further and financially sound enough to ensure that the product reaches the ultimate goal of serving every citizen of this country. All these aspects will be looked into it. And if they are satisfied, they will give the green signal. And with that, we can have a non-exclusive agreement so that we will be able to license you for production of it in India. So this is how the whole the process goes. And when it comes to technology readiness level, we do have right from the laboratory level to, let us say, up to technology readiness level of 3 to 4 to all the way up to 6, 7. Up to pilot plant demonstration is definitely within our purview. Where it is feasible for us to demonstrate, where there is a definite need for it, we take it up to pilot plant. So this are the major points I thought I should cover at the initial remark. I'm not sure whether I have already overshot the time that has been allotted to me. But this journey has begun for us. We are young. We started like a kid. We didn't know what to do. Now we are definitely adult. We know how to walk. We know how to run. But all this journey has no meaning unless otherwise the journey is together. The journey has to be together with you. So there are two ways you can approach us. If you, with our expertise has been told to you, and you will also understand from the presentations, and if you have anything that we have already developed is of interest to you, kindly go ahead. That is one possibility. Second point is that you have certain interests. There, please don't ever hesitate. Let it be on anything. I'll tell you one small example, probably that will be the last one. Sorry, madam, I'm crossing my time. Should I?
Please go ahead, sir.
Thank you. I'll just finish it off with one example. Way back, one cardiologist, sorry, what do you call that? One cancer specialist, director of Malabar Cancer Center entered our building. He said that I came to Medical College of Thrissur. I saw one research institution. What is this? So I entered. You will see that product that has come out of that, which has got a lot of societal importance, went into Cmet Presence Network. It was a collaborative effort because there was a requirement, and he came and told that I don't know what you people are doing. You people may not understand what I'm going to talk to you. Doesn't matter. Can we sit across the table and understand each other and shake hands? That has been a very good beginning for us. That project was taken up by Cmet, and CDAC at Trivandrum helped us, and MCC at Kannur did the entire field testing on patients on a block panchayat. Every woman was screened. So all these things, what I'm trying to tell is that you have anything, sir, our startup, this is what is the idea we have. This is where we will see whether it falls under our area. Any expert is available, definitely we will link it. Otherwise, we will definitely tell you if other experts are available in other two centers or in any other institutions within India. Thank you so much for the time, the opportunity given, and patience. Thank you so much.
Thank you, sir. Thank you for the very positive words. The journey is together. Yes, the journey is definitely together. So let's move to the highlight of the day, the demo. And also thank you for explaining the activities in Cmet and the opportunities for the stakeholders, and also giving a brief intro about the product and the product owners. It will be 11 products from Cmet that will be showcased today. The respective product innovators will be sharing the product opportunities one by one, requesting all of our guests and participants to interact with each presenter soon after each of the presentation. A 5 minutes product presentation and 5-minute interaction is planned for each product. Aerogel capacitor, supercapacitor by Dr. Stanley Jacob, NTC fast response thermal sensors, digital thermometers for industrial and laboratory use, graphene supercapacitors, solar lanterns, thermistor-based digital thermometers for clinical applications, wearable device for breast cancer screening. The 6 products will be dealt by Dr. A. Seema. Transparent heater, transparent conducting lines, fiber optic prop for portable sensors, portable biosensor with disposable chip. The 4 products will be dealt by Dr. SN40. So without further ado, let me welcome Dr. Stanley Jacob for the presentation. Sir, please.
Good morning to all, and thank you very much, Salini Madam and Rink for giving us a chance to project our aerogel supercapacitor technology. So I will straight away move to my presentation. So I am switching off the video and I hope my video is, slides are visible to you, all of you?
Yes, sir. Can you maximize it?
Yeah,
it is
I
visible.
have done it, but now
yes,
it is.
Sir. It is perfect.
Okay. So as the Raghu sir has mentioned, I am going to discuss about the aerogel supercapacitor technology, which has been developed by the Aerogel and Energy Materials Laboratory of Cmet. As most of you knowing, supercapacitors are electrochemical energy storage devices. They have higher power capacity and fast charge discharging characteristics and highest electrical energy storage capability and wide operating temperature, and their cycle life is also very high, approximately around 1 lakhs. And their size is compared to conventional capacitors, it is very small. You can see a small our 25 farad supercapacitor and a 35 microfarad electrolytic capacitor, and how size is different. And if you compare the power and energy characteristics of this capacitor and battery, the supercapacitor comes in between conventional capacitors and batteries. And the supercapacitor finds a lot of applications in starting from a small toy to a missile. Major application areas of supercapacitor is consumer electronics, industrial, machineries, strategic applications, and transportations. And if you see the market requirement, as per that IDX study, currently the requirement of supercapacitor market is almost 2.92 billion, and it is going at a rate of growth rate of 30% and will reach almost 8.3 billion US dollar market. And in our Indian scenario, if you study ELSINA, that is Electronic Industries Association of India, has carried out a study, and they also find that our Indian demand is 1.3 billion units, costing approximately equal to 13 billion Indian rupees under various sectors like automotive, rail, wind energy, solar lighting, consumer electronics, etc. And coming to our technology, why carbon aerogel supercapacitor? Actually, supercapacitor is made up of 2 symmetric carbon positive electrodes separated by an ion permeable electrode. The major characteristic of a supercapacitor is determined by the electrode material. Currently, activated carbon is commercially available. Activated carbon is used as an electrode material by commercial manufacturers. Problem is that if you see the mechanism of charge storage, it is an electrical double layer capacitor formation. So this whatever ions present, when we charge this capacitor, whatever ions present, it gets absorbed on the carbon electrode and will form a thin dielectric medium. Because of the smaller thickness of the dielectric medium, which is in the range of Armstrong, and high surface area of that electrode material, we are getting very high capacitance for supercapacitors. So the problem is that in activated carbon, most of the pores are in below 2 nanometer range. That means our ion size is bigger than 2 nanometer. Most of the ions cannot penetrate into these micropores easily. So even though the activated carbon materials are having higher surface area, they cannot be fully utilized. Here, this aerogel, as Graves sir has mentioned, it is one of the lowest low density material available. Here, carbon aerogel is a aerogel material, which is a three-dimensional network structure material. Because of that three-dimensional network structure, it has got high electrical conductivity, and its surface area also very high. Here, another advantage is that we can tune the porosity of this carbon aerogel. That means we can see this carbon aerogel, we can make both micropores, mesopores, and macropores. So these mesopores and micropores are utilized as a super highways for the easy movement of electrolyte. So carbon aerogel is an ideal electrode material for supercapacitor. Carbon aerogel also finds applications other than supercapacitor, like fuel cells, hydrogen storage, gas diffusion, catalysis, water purification, and all other so many applications. Coming to our technology, Cmet has indigenously developed carbon aerogel and demonstrated its preparation in kilogram batches using a pilot plant facility created at Cmet Thrissur. Generally, carbon aerogel is prepared in a two-stage process. First, we have to make a organic aerogel. Then that organic aerogel is converted into carbon aerogel by inert atmosphere heating. Why organic air? Why this? How these aerogel materials are getting high porosity? If you dry a gel material in a normal atmosphere, we will end up with a material called zero gel with a low porosity. If you do a special drying process called supercritical drying, we can end up with a aerogel material with lot of porosity without shrinkage. That is a methodology adopted for making carbon organic aerogel. So Cmet has adopted supercritical drying using liquid carbon dioxide, and this whatever liquid carbon dioxide facility we have created is a recyclable. Whatever used carbon dioxide is reused again. So this is an environmental friendly plant, and we have demonstrated in kilogram batch we can make up to 3 kg of carbon aerogel. This 3 kg of carbon aerogel is 1 kg of carbon aerogel is equivalent for making 10,000 number of supercapacitors of 1 farad. After making this carbon aerogel, next we have developed carbon aerogel tapes using this carbon aerogel powder. This carbon aerogel powder then converted into supercapacitors. As we can see, this we have to arrange this supercapacitor facing it in a sandwich configuration. In between the electrode, there is a separator. Then we have to wind it and insert inside a aluminum can, and then we have to fill a electrolyte. That electrolyte determines the working voltage of this supercapacitor. After this electrolyte filling, we have to do sealing and then finally electrical testing. In Cmet, we have almost all the machineries available for making carbon aerogel powder to supercapacitors. And most of the 90% of the equipment, except some electrical characterization, most of the equipments are indigenously fabricated. And we also fabricated aerogel supercapacitors of cell capacitance 1 to 50 farad. So this technology has been segmented into 3 main major phases. First phase is carbon aerogel preparation. Second phase is electrode fabrication. And third phase is supercapacitor fabrication. And these are the properties of the aerogel supercapacitor we have developed in this technology. And we have, as I said, we have made 6 products having cell capacitance varying from 0.47 to 50 farad. And these are cylindrical cells with leads type, and their size varies from 16 mm to 20 mm to 25 mm to 42 mm. And their operating voltage is 2.5 volt for single cell, and their surge voltage is 2.7. And our ESR of this aerogel supercapacitor ranges from 1.5 ohms to 0.135 ohms. And their energy density also as par with the commercial capacitors. And these are some of the demonstrations we have done using carbon aerogel supercapacitor. And here this is an emergency light. Here we have connected 2 supercapacitors, and this will take only 2 minutes time to charge these supercapacitors. And this emergency can give light up to 1 hour without any interruption in full brightness. And these are the DC motors working with a supercapacitor without any battery. And we also demonstrated some toys using these supercapacitors. These are for the to show the demonstration of prototype supercapacitors we have made. And this technology, after developing this technology at the TR level of 5+, this Cmet has invited expression of interest from various industries, as Ravi sir has mentioned. So those industries can approach Cmet, and this advantage of this TOT is that if any party is interested in any one of the phase, they can also take that phase, or they want to take segment wise, or entire can also be taken. This phase 1 TOT cost is coming around 7.7 lakhs, and phase 2 it is that means carbon aerogel making, that is 7.23 plus tax, and phase 3 is production of supercapacitor aerogel, that is 7.89. So entire phase 1, 2, and 3 cost is coming around 20.61 plus taxes. So anybody interested can contact Cmet, and we are also extending our facilities for the industries for carrying out trials of their material. For any more information, please contact the Director, Center for Materials for Electronics Technology, Cmet. Thank you. Any questions, please?
Dr. Stanley, hi, this is Nizam here from Maker Village. We are already connected with Cmet on several levels, as Dr. Raghu mentioned in the beginning. However, this question is more from the startup side that I want to ask. Do you help in identifying any commercial, use cases or etc. for such for the products that you're developing? That would actually help the startups in identifying new areas of application or things like that.
Sir, that is definitely part of our mandate. We will definitely welcome it. And being scientists, we will have our own limitations that may also need to be understood by the other side. And definitely shaking hands, as I mentioned, is feasible, and
Sure.
the journey has to be together.
Okay.
Thank you,
And
sir.
on this particular this one aerogel that you said that you're already producing like 3 kilograms of carbon aerogel, right? So do you sell that as a separate product, or are you looking to only license the technology or something?
Carbon aerogel is one of the TOT phase 1. It is available for technology transfer.
No, I'm asking the product itself. That carbon aerogel, would you sell that as itself to any?
No, we are not selling it.
Okay.
Sir, we are not being in R&D institutions. We cannot sell. We are not commercial entity.
Okay.
So we develop it. That is why we give the know-how to transfer it so that others can produce it. And through that journey also we will be there.
Understand. Thanks for the clarification. Thank you.
Thank you, sir. Thank you so much.
We have a question from Ansil. Can this aerogel capacitor can be used as a battery for EV?
Actually, the supercapacitor can work along with battery for electronic applications. In smaller like toys and all, battery can be replaced completely. But most of the cases, supercapacitor will support battery for electrical application. For some application like cranking of these vehicles and all, we can use supercapacitor.
Essentially, when
running the electric vehicles, we need a support of both battery, that hybrid of supercapacitor and battery. For some small applications like this cranking, we can use supercapacitor.
Essentially, when you switch on the vehicle, there is a lot of power requirement coming into picture. That portion will be taken care by supercapacitor, and whenever there is a energy requirement coming to picture, battery can take over. So the combination will always give a better performance.
Any more questions, madam?
one general question is there in the question and answer box. Do you have technology to produce nano titania particle with 5 nanometer size? One of you kindly go answer, please.
Sir, actually, we have prepared titania aerogel particles of this whatever size required. If they are interested, they can directly contact us.
Thank you.
Thank you, sir. Then we will move to the next presentation. I would request Dr. Seena to present this. Ma'am, please.
Good morning to all. Stanley, can you stop your sharing of your screen, please?
I already stopped it.
Sir, it is visible here.
Please 1 second.
All our products, we have 6 products from our group, and it will be discussed by the expert in that particular domain in our group. So the first product is on NTC fast response thermal sensors, and it will be shared and discussed by Dr. M.N. Muralidharan, scientist, Cmet.
Thank you very much. I am Muralidharan. I am working with Dr. Seema. We will be having a video presentation for the NTC fast response thermal sensors. After that, I will be happy to answer any of your questions there. Let me share the. Is it visible now?
Sir, yes, but yes.
Yes.
Center for Materials for Electronics Technology, Cmet, is a research and development organization under the Ministry of Electronics and Information Technology, Government of India. Cmet is engaged in the development of cutting-edge technologies in the area of electronic materials, components, and devices. As a part of its mission to become a source of critical electronic materials, know-how, and services to Indian industries, Cmet has developed an indigenous technology for thermistor-based fast response chip and chip-in-glass thermal sensors. The global thermal sensor market was estimated to be more than $7 billion in 2019 and is expected to continue a steady growth in the coming years. Asia Pacific region, including Indian market, is predicted to grow with a cumulative annual growth rate of more than 5% from 2020 to 2026. Presently, China and South Korea dominate the Asia Pacific thermal sensor market. However, with the new government initiatives such as Make in India and Atmanirbhar Bharat campaigns, India can evolve as a leading competitor in the production of thermal sensors. The most commonly used thermal sensors in the industry are thermocouples, resistance temperature detectors, thermistors, and semiconductor-based ICs. From a general comparison of the properties of various thermal sensors, we can see why thermistors are the most widely preferred thermal sensors in the market. Their fast response, low cost, high accuracy, and high sensitivity have helped thermistors to cement their place as the most sought after thermal sensor for a variety of applications. Negative temperature coefficient of resistance or NTC thermistors are used in various forms such as beads, discs, rods, and chip thermistors. Among these, chip thermistors have been the industry favorites because of low batch-to-batch variations fast response, and high accuracy. Cmet has developed an indigenous technology for NTC thermistors, including various material compositions and processing technology for chip thermistors, epoxy encapsulated chip thermal sensor probes, and chip-in-glass thermal sensors. The selection of a particular type of thermal sensor is based on the requirements of the application. For instance, the epoxy encapsulated chip thermistors can work only up to 150 degrees centigrade, whereas for high temperature applications, chip-in-glass thermal sensors which have a higher working temperature of 350 degrees centigrade or above will be more suitable. NTC chip and chip-in-glass thermal sensors can find variety of applications including consumer electronics such as in air conditioners, washing machines, automobiles, and so on. To cater to the wide spectrum of applications, Cmet has developed various compositions for both high temperature and low temperature applications. As an outcome of the efforts to use the thermal sensor technology for various applications of societal significance, Cmet has also developed many other technologies using the thermistors developed by Cmet, such as thermal sensor based wearable device for breast cancer screening, clinical digital thermometers, industrial digital thermometers, and so on. Cmet has a dedicated pilot plant facility for NTC thermistors for demonstrating the scaling up feasibility for commercial production. Cmet has developed sub-millimeter sized chip thermistors as small as 0.2 mm by 0.2 mm. Cmet has also developed various compositions with different resistance temperature characteristics and sensitivity so that it can cater to the wide spectrum of applications. The testing and characterization of the thermal sensors for their thermal and electrical properties were carried out as per international standards. The electrical and thermal reliability test shows that the NTC thermistors have excellent reliability. With this indigenous technology, we can play a major role in the global thermal sensor market and substantially contribute to the economic growth of our country. Let's work together to accomplish the dream of self-reliant India, Atmanirbhar Bharat.
This is about the NTC thermistors. If anybody has any specific questions, I will be happy to answer. I think if we don't have any specific questions, we can move on to the next presentation. That is for digital thermometers for industrial and laboratory use. That will be discussed by Mr. Rashid.
Good morning, all.
Sir, a quick question.
So you mentioned that different applications of the thermistor sensors. So how is it different from the conventional tech that is used in automobiles and different other applications? Or is there any innovative tech behind this new chip-enabled thermistors?
Yeah, basically the most important parameters of thermistors are the sensitivity and how accurately we can measure it. So we have individually calibrated thermistors what we have developed. We can accurately measure up to like plus or minus 0.001 degree centigrade. We have a wide spectrum of thermistor composition which can fit into each and every application that you're looking for. For example, if we have a low temperature application, which can go up to minus 90, we have a specific composition for that. Normally, those kind of sensors for low temperature applications and all are not available in the market as of now. So those kind of specific applications, we will be able to deliver for a particular application, fine-tuned for customized applications also.
Got it, sir. So basically, you can customize it for any kind of requirement based on the sensitivity and other parameters.
Exactly.
Okay, thank you. So this
I
is
have
also
a kind
open
suggestion.
to be.
Yeah, sorry.
Yeah,
I have a kind suggestion.
So,
while answering questions, also kindly look at the chat box, because there are certain questions put in this. Some people put in the chat box and people are asking in the Q&A. So kindly look at that also, then clarity will come. Thank you.
Thank you, sir. Let's move on to the next presentation.
No, I think that gentleman had one more question to ask. I interrupted, sorry.
no, sir. I mean, I was asking whether, like the last product presented, this is also open for engagement from the industry, right?
Absolutely, absolutely.
Okay, thank you, sir.
Salini madam, we can move on.
Yes, sir.
Now we'll move on to the next presentation.
Good morning, all. My name is Mohammed Rashid. I am a project staff at Cmet. Me and our team have developed an industrial digital thermometer. The video is made about industrial digital thermometer. You can see this video also. After the video, you can ask the doubts about industrial digital thermometer.
Cmet aims to develop a variety of products by part of research and development. Currently, the focus is on the modern technologies. Mercury is a harmful and toxic element which is to be reduced. Otherwise, it can contaminate our body as well as surrounding areas unsafe. It is to be noted that these thermometers are used even for food materials, putting human life in risk. Cmet has launched an effort to reduce the use of mercury-filled thermometer by introducing industrial and laboratory digital thermometer. Our industrial and laboratory digital thermometer is equipped with these unique features. It has a temperature range from minus 10 degrees Celsius to 110 degrees Celsius, and it can collect up to 3100 readings through data logging, and it provides an accuracy of plus or minus 0.5 degrees Celsius. Three switches are provided for easy operation. It is equipped with industrial grade SS316 stainless steel probe. For data logging, Android and Windows applications are available. Our specially designed industrial and laboratory digital thermometer can be used as per user needs with or without data acquisition system. In without data acquisition system, the thermometer acts like a normal digital thermometer. Two AAA batteries are used in this device, and by its sleek design, battery can be easily replaceable. You can see three switches in front of our device. One for power on the thermometer, next one is for to switch the thermometer into data logging mode, and the third one is for hold your readings. The data acquisition can be done by using dedicated standalone application developed by Cmet. You can set the duration of digital thermometer by using our application and safely place the thermometer on site and can move to another works. Your thermometer will monitor the data and you can retrieve it when you are free. In addition to these, we can save the data into a text file for future analysis. We believe that it is an important factor to create a unique design for our product. Indian Patent Office has granted the design registration for our industrial and laboratory digital thermometer. Increasing demand for industrial thermometers across various end-use industries is anticipated to fuel the growth of industrial thermometer market. Rising number of industries related with chemicals, research centers, food industries are some of the growth drivers of industrial thermometer market. We can look through one of the topmost milk industry in India. In various stages of their production, they need to measure the temperature at the different platforms. Additionally, increasing demand for accurate and precise temperature reading in many industries have led to the manufacturing of digital thermometers. This has resulted in increasing demand for high-end industrial thermometers in last couple of years. Increasing usage of phased-off mercury thermometers to hamper the growth of the industrial thermometer market. Due to the restrictions on movement at international borders, the supply chain of major players has been interrupted, thus created an opportunity for local players to enter the market. Let's compare our industrial and laboratory thermometer with other industrial thermometers in market. By analyzing the market surveys, we can understand that Indian market is flooded with non-quality products. Indian government is developing the domestic production with the support of new economic schemes to the civilians. With the help and support, we can rise the nation into the top of the world.
Thank you all for watching the video. Now you can ask any question regarding this product.
A quick question here. Apart from the industrial usage, there could be a lot of application in terms of residential usage, wherein cooks can use this for, as you showed in the beginning, right, for measuring the temperature of the food and all. But the upper limit of the temperature, 110 degrees, is that limit, can't it be increased more? Because in the food definitely would be more hotter and everything like that, right? So is there any way to improve that?
Yes, we can increase the range also. We have developed this product for only for industrial and laboratory purpose. So we in the market, the normal mercury thermometer is in the range of -10 degrees Celsius to 110 degrees Celsius. So according to that, we have developed this product. So we can, if the customer need a big range, around 150 or 200, we can also make that also.
Yeah, okay. I was just looking at the commercial application of that one, right? Because it could be definitely extended to this restaurants and other food commercial food preparation, and also for home usage and all. So if someone had any idea or something like that on that lines, so that could be applicable. Thank you.
Okay.
Dr. Seema or Dr. Muralidharan would like to add on to that?
This is Muralidharan here. Actually, to add on to what we have discussed now, for example, for food service applications, if you want to go for a negative temperature, basically for logistics, transportation of food and pharmaceutical, those kind of things, we can go up to something like normally required will be -50 or -70 and those kind of temperatures. The same thing can be extended to this lower temperature as well as higher temperatures also, depending on the specific application. Only thing is that we may have to tune the electronic part of it, and also we have different types of sensors for each category. This is what I would like to add on to that.
Thank you, Dr. Muralidharan. Any further questions? Shalini madam, we can move on to the next one.
Yes, sir.
Our next product is graphene based supercapacitors. For detailing the product, I am introducing Mr. Jimmy Joy.
Everything depends on energy nowadays. Your mobile phone, your house, your city, and our entire world. Incredible amount of energy are produced every day worldwide, using traditional methods like combustion of fossil fuels or through sustainable technologies such as wind turbines and solar panels. We can all think of one way of storing energy: batteries. Just think about your mobile phone and laptop. They both use batteries. Unfortunately, they cannot be charged as fast as that will be necessarily in case of energy access. Capacitors are another way of storing energy, and in contrast to the batteries, they store their energy electrostatically. What are supercapacitors? A supercapacitor or supercap is an energy storage device similar to battery. Battery releases energy from chemical reactions. Supercaps generally store energy from static electricity. Why supercapacitors? Why not batteries? Aren't batteries sufficient? For some applications, batteries are the best selection. But when you want to charge or discharge rapidly, supercapacitors are the preferred option. Moreover, the cycle life of supercapacitors are much longer. Graphene. Graphene has emerged as one of the most promising nanomaterials. It has received a rising attention in numerous energy conversion technologies due to its unique characteristics in mechanical, electrical, and thermal conductivity. Cmet has developed a variety of graphene-based supercapacitors such as 0.5 farad coin cell, 1 to 100 lead type cylindrical supercapacitors, and 100 farad to 200 farad snapping type supercapacitor. Supercapacitors have a lot of advantages, and may one day it will replace batteries. First, they charge ridiculously fast. They have a virtual unlimited cycle life. They were better than batteries at extreme temperatures, and they also have higher power density than batteries. In other words, they transfer energy much faster. Cmet has developed 10,000 microfarad 14 volt coin cell module and 16 volt 70 farad power module. Power module has been developed using indigenously fabricated 2.7 volt 200 farad graphene supercapacitors having ESR ranging from 6 to 8 milliohm. 200 farad sorted supercapacitors were connected in series parallel combinations to form the power module. This power module was tested by using it for powering numerous DC and AC applications. The power module was used to rotate two 15-volt DC air fans. To analyze its use in AC applications, an UPS was dismantled and the battery was replaced by supercapacitor power modules. It was found that the modified UPS was able to provide an AC output of 230 volts. Supercapacitor-based power module was also able to power 22-watt AC exhaust fan and 3 9-watt LED bulbs effectively. Supercapacitors are a perfect fit to mitigate peaks and steady grid, thus can easily handle power fluctuations. Due to very fast charging and discharging, supercapacitors make a great tool for regenerative braking. Our supercapacitors can be applied in various fields such as consumer electronics, startup mechanism for automobiles like hybrid and electric vehicles, and many more. Let's work together for an energy efficient future.
Thank you all for watching the video. Hope you all had enough information from the video itself. If you have any queries or doubts regarding these graphene supercapacitors, kindly please ask.
Thank you, sir. I would request the entrepreneurs to understand from these scientists the business opportunities, the how the technology transfer can be done, the processes involved. I am requesting all the participants to kindly ask questions if you have.
So there is a question on the chat box. Dr. Sina from Indian Institute of Space Science and Technology, Trivandrum, is asking regarding the mode of collaboration with research institutions or academia. So she's asking their research focuses on MEMS sensors and energy harvesters. They are interested in exploring collaboration with Cmet. They would like to know how can they do it.
We will be more than happy to collaborate with academia as well as the institutions. Absolutely no problem. Already, as I mentioned in the initial stage, we had a collaboration with our own CDAC and Malabar Cancer Center like that. So I told you that we have with Digital University. So Makers Village is Mr. Nizam is there. So like that, we have a variety of collaborations with other institutions as well. It is most welcome. Madam, kindly contact the concerned scientists. And if you want the general email ID, CMETT, add one more T. CMET stands for Cmet, and add one more T for Trishore. At the rate, again, cmet.gov.in. Definitely, it will be forwarded to the concerned scientists who will be able to collaborate with you. Nothing on earth is feasible by standing alone, and it has to be in collaboration. Most welcome.
Adding to what Raghu sir has said, Seena ma'am, we have this Rink portal, and Cmet is already there. You can individually go and see the products there, and also the product owners. So you can write to them directly from the portal. Thank you so much.
Thank you, Salini madam. Are there any further questions, or should we move on to the next one? Madam, kindly go ahead.
Yes, sir. Let's move to the next presentation.
If there is no any other specific questions, I would like to introduce Joe Varghese for introducing the product solar lanterns.
Considering the importance of social and rural development, Cmet has developed various electronic products as part of research and development. Light, the essence of life itself. Access to electricity can improve socio-economic conditions in developing countries. In rural India, most of the people are struggling without electricity. The major problem we face that after sunset, kerosene lamp or candlelight is the only source of hope for children to light up their future. Another issue of concern is indoor air pollution. The use of kerosene lamps, which results in substantial emission of the air pollutants that causes severe health issues. Working hours of shopkeepers and daily wages are reduced to minimum due to lack of light, which affect economic growth of the nation. Not only the working sector, but also households are struggling by lack of light. Another challenge is rural electrification. Although 96.7% villages in India are electrified, still they are getting electricity only for a limited period of time. Realizing these difficulties, Cmet has developed solar lanterns which can brighten up their lives. The solar lantern we developed is economically viable. We have developed a wide variety of solar lantern with different specifications. The first variant with battery alone provides solar charging along with charging using mobile adapter. In addition, the variant can be modified to include FM radio. The high power LED used in the torch light can cover longer distance. The next variant uses 3.8 volt hybrid supercapacitor using faster charging feature. The cheaper variant of the same include a normal 2.7 volt supercapacitor with SMD LED strips. The faster charging feature will be a perfect fit for urban people who lead a busy life. The next variant, which is hybrid solar lantern, provide faster charging feature of supercapacitor along with longer duration of battery. It can be charged in less than a minute for quick emergency purpose. Cmet has already got the design registration and invested in the production of more. Therefore, there is no need of huge investment for an entrepreneur in the production of mold. After the complete in-house test, Cmet plans to certify the product under MNRE norms. India represents 30% of the global volume share and revenue share for the solar product. It still remains the single largest market for portable solar lanterns. India being the largest consumer for solar lantern, inefficient and non-durable Chinese lanterns consumes India's market. Knowing this, the government of India under Atmanirbhar Bharat scheme has invested 20 lakh crores for implementing reforms across various MSMEs. In the current market, there are two types of solar lanterns available: basic solar lantern and advanced solar lantern. The advanced solar lantern which we developed is far superior than the other with inbuilt solar panel, lithium-ion battery and advanced features like faster charging, FM radio and brightness control. The global market study indicates that over past few years, the use of basic solar lantern has reduced to minimum in both urban and rural areas. On the other hand, the use of advanced solar lantern with multiple features have increased and continue to grow. Basic lantern, which were originally provided only to cater lighting needs, now evolved to include multiple features such as battery performance, illumination control, inbuilt solar panel and FM radio. The solar lantern developed by Cmet with its unique features which can cater both rural and urban needs will conquer the global market. The use of solar lighting dates back to 1000 years ago when man first discovered fire. Our solar lantern is here to stay until the sun shines its last beam. And as technology advances, the development can grow over and over again. Let's join our hands together for lighten up the future.
Good morning, everyone. I am Joe Varghese from Cmet, and I am representing this product, Solar Lantern. If you have any queries about this product, please ask.
Are there any? Yeah, please kindly go ahead.
Hi, this is Pyalal from Cochrane Solution. We are into parking automations, and we are looking for solar roof technologies to integrate in our parking solution. So would like to know any such research is happening in your domain.
Dr. Seema, Dr. Muralidharan.
This is Muralidharan here. Actually, basically the solar panels we are not working on. What we are talking about is about solar panels. We have some other groups working on photovoltaics, but presently in our group we are not working on solar panels. Basically, we are working on solar lanterns using supercapacitors or batteries or energy storage devices. So we have people who are working on photovoltaics. I think Rivsa will be able to guide you to.
Okay, sure.
Yeah, if there are any specific applications that you have in mind, we will be very happy to see how best we can have the journey. Because there are certain, as Dr. Muralidharan was mentioning, there are certain basic studies we definitely did with solar photovoltaic kind of a thing. And not only at Thrissur, I think Pune is also took care in doing the material part of it.
Okay.
So, and there is a big program Cmet Hyderabad is planning on utilizing amorphous semiconductor based, that is national, not even national program, it's actually an international program under international collaboration that is still at the discussion stage, but every feasibility is there.
Okay, okay.
Thank you.
Thank you.
I think in chat box we have one question for whether we can go for solar light street lighting applications. In this connection, I just wanted to as we discussed now, we are basically not working on photovoltaics, but the other side of the part, like solar lights and energy storage part, that we will be able to do. But it depends on what is the requirement, and after having some discussions.
Any further questions, please?
Sir, Dr. Umar Salim has a hand raised. He would like to talk, sir, please.
Yes. Good morning, all.
Good morning, sir.
Actually, with regard to the domain of organic photovoltaic (OPV), now we have OPV is still in the progressive stage, developing stage. So can we know for electrophoric and electrochromic display, where there is only less energy storage is required, any sort of development is happening in India? If so, what is the current status, and where we can get the depth now of the substrates, the coating of this OPV?
I would request Dr. Stanley or any other scientists from Cmet who are available in the forum to give clarity, please.
Regarding the organic photovoltaic, NIST is having a wonderful group there, Dr. Narayan Unni.
Come again, sir. Which is that group?
That NIST, no? Random NIST.
Initially, it was Regional Research Laboratory at Trivandrum. Now it is named as NIIST. It is a CSIR lab.
Okay,
at
CSIR.
Trivandrum.
Okay.
Yeah. Kindly contact them.
Okay. Thank you.
Madam, are there any further questions?
So no questions are not in the chat or in the Q&A box. Can we proceed to the next presentation?
Yeah, kindly go ahead, madam.
Okay, thank you all. So our next product is thermistor-based digital thermometer for clinical application. So I invite Ms. Ashna for detailing that product.
Cmet has developed various electronic products as part of research and development. Considering the current pandemic situation, which lead to a dramatic loss of human life worldwide, body temperature being initial warning to the infection, and also temperature measurement is a primary concern nowadays. Cmet plans to fight against this war by developing clinical digital thermometer. In future, clinical digital thermometer are preferred worldwide over mercury thermometer because of easy measuring and longer life and no part of mercury poisoning. Cmet introducing clinical digital thermometer which is easy to use and highly accurate. The idea is that you can wash the thermometer under tap water after every use, so that we can avoid cross-infection between the patients. What makes this product truly unique over other thermometers? By its unbreakable feature. Don't afraid if it's dropped from your hand or your child throws like a toy. The clinical digital thermometer is developed by using indigenously available components except IC and LCD display. This unique design got design registration and the mold for the case is already made by Cmet. Indian Patent Office has granted the design registration for the design of the clinical digital thermometer to Cmet. The accuracy of clinical digital thermometer was tested using a constant temperature bath and our thermometer shows 0.2 degrees Celsius accuracy. The Indian market is flooded by Chinese product and its quality is not tested or reported. Hence, the Ministry of Health and Family Welfare restricted the importing of medical equipments like digital thermometer without the approval license of Central Drug Standard Control Organization effective from 1st January 2021. As per the Ministry of Consumer Affairs, Food and Public Distribution, certain medical devices has to be qualified as notified by them on 2011. However, the same was not implemented till June 2021. From July 2021 onwards, imported digital thermometer which was not qualified as per their standards cannot be sold in India. Clinical digital thermometer developed by Cmet has tested and qualified as per Class 2 standard of Ministry of Consumer Affairs, Food and Public Distribution by a NABL accredited laboratory. Clinical digital thermometer has qualified Indian standard IS 15113-2002 for medical purpose. The tests include electromagnetic compatibility testing, water resistant testing, thermal shock testing, and mechanical testing. We have tested the clinical digital thermometer for ROHS compliance at the NABL accredited ROHS laboratory of Cmet, Hyderabad. We are happy to inform that our product is ROHS compliant. By long press, you can turn on the thermometer, then you can see your previous temperature value. Beeper to ensure that measurement is completed. Our clinical digital thermometer is convertible in both degree Celsius and degree Fahrenheit by a single press. In addition to this, our clinical digital thermometer is 100% waterproof. Features of clinical digital thermometer. Automatic switch off, long-lasting battery, completion alarm, medical grade accuracy, easy to operate, degree Celsius, degree Fahrenheit mode, guaranteed accuracy, one button operation. And also it is ideal for both pediatric and adults. We can compare Cmet clinical digital thermometer with other thermometers in the market. As per the recent survey by Grandview Research USA, the global thermometer market size was valued at $769.3 million in the year 2016. According to survey, the key drivers include increased application of the system in the temperature monitoring for medical. The outbreak of COVID-19 has created large-scale opportunities for local manufacturers. The rising number of cases has led to a shortage of medical supplies. Thus, local players are manufacturing product on a larger scale to meet the growing need. It's time to penetrate the world market. Let's together make it happen. Our clinical digital thermometer will conquer the global market by its unique features.
I am Ashna from this project. I am representing the clinical digital thermometer. If you have any doubt regarding this presentation, can you share with me?
In case there are any questions, kindly go ahead.
I would request the participants to ask questions in case of any clarification required, or to know the business opportunities, how to get the technology transfer and the processes included.
If there is nothing much, madam, we can move on to the thing. And anyway, they have the email ID and the website. They can always contact us at any point of time. Thank you so much. Madam, kindly go ahead.
One second, sir. Mr. Hari Krishnan has raised his hand. 1 second.
Kindly, madam.
Sorry, Mr. Abhilash. Abhilash, would you like to ask?
Yes, yeah. I basically wanted to understand whether Cmet is going to productize it or planning to transfer it to other organizations to the design so that it is scaled up and developed. What is the idea behind it? Just
Sir, thank you so much. Actually, probably you are not there at the initial stage where I had explained with clarity, as well as when Mr. Nizam was asking from Makers Village, the same clarity was given. No problem. I'll repeat it again.
Sorry.
That ours is a research institution. So we cannot produce. Okay? So we can develop it, we can demonstrate it. We try our level best to do it at pilot scale level so that it becomes a little more easier for industries to understand and take it further. But we are there together in that journey. So we will give the know-how. We will give it on a non-exclusive basis with the clarity on agreement and other terms and conditions. Once that process is done, you can start, we will give you the license for producing it in India. You can put up, and in that journey also, wherever help is required, Cmet will be more than happy to help you, sir.
just to clarify, so this is already a product, right? Or is it more at prototype stage, or is it because you had tested it and you had verified?
Which one specifically you mean, sir? You mean all the products, or you mean specific
No, specifically the digital thermometer. That was
Dr. Seema, Dr. Muralidharan?
Yeah, I would like to add here. Actually, this is at a TRL level of something like 7 or 8 years ago, because it's not a prototype. It's already tested and like field trials, into field trials now. Like it is at that stage. Like whatever the mandatory requirements, like IS, what you call certification for IS standards, the testing standards, all those things have been already done. ROH compliance, all those things have been already done. So whoever takes the technology, they will be able to directly go for the productionization.
Sir, I also would like to add here that if I remember right, for all these products, we have that copyright for the design.
Thank you. Yeah.
Thank you. Madam, kindly go ahead, madam. Dr. Seema, you would like to add something? Please.
Let's move to our next product, wearable device for breast cancer screening. It is represented by Ms. Arati K.
In India, breast cancer ranked first among the cancer found in women. It's also observed that there is a steady increase in breast cancer in younger women in our country. The early detection of breast cancer can lead to 100% cure of the disease. Mammography, the golden standard of care today, is an X-ray technique and it is not very effective in younger women. Breast thermogram is a temperature profile of breast and it's a valuable tool for early cancer detection. Every woman will have a unique breast thermal signature and it will be altered by abnormality due to high metabolic activities in cancer tissues compared to normal tissue. These changes are well detectable by a regular thermal screening at much earlier stage. However, IR thermography is not feasible for regular screening due to high cost, low accuracy and lack of privacy. Cmet Thrissur have developed thermal sensor based wearable device to detect breast cancer at an early stage. This device is non-invasive, radiation-free, portable, low-cost and suitable for women of all ages. Most importantly, it ensures the privacy of women without compromising accuracy. This device is in the form of a vest that contains highly accurate thermal sensors indigenously developed by Cmet. A gown can be worn above this wearable device. This device will collect the temperature data of the breast for 15 minutes by using a portable data logger. These temperature will be fed to our analysis software, which uses 3D thermal image reconstruction algorithm and artificial intelligence to predict the location and size of the abnormality. The analysis software has a graphical user interface. The analysis reports are automatically saved with the unique ID of subject provided in the interface. The raw temperature data will be stored and the same can be used for further analysis by a medical practitioner so that the recalls can be avoided. The graphical user interface delivers cutting-edge technologies that produces 2D and 3D thermal images of the breast. The medical practitioner can interact with our 3D thermal images in all angles and he can easily find out the abnormality. This analysis system generates reports automatically. It contains location and size of the abnormality, the 2D thermal images of the breast surface, the vertical horizontal slice of the breast at abnormality are also included in the report. The generated reports are user-friendly and even a healthcare worker can interpret this report. After acquiring required ethical clearance, the device has undergone clinical trials at Malabar Cancer Centre, Talasheri. We have tested the wearable device in proven malignancies as well as in volunteers. In most cases, the result obtained were in line with the standard diagnostic tools like mammogram and sonogram. The sensitivity of the device is more than 95%. The automatic report generation system were also validated. Both the positive predictive value and negative predictive value was 72%. A no objection certificate is already obtained from Central Drug Standard Control Organization and the Director General of Health Services, Government of India, to the company who have taken up this product. The entire system cost only 50,000 rupees. A woman can have a wearable device of her size with her for regular screening, which will only cost near 500 rupees. The analysis system and the data logger in a technical laboratory can be used by the same woman for regular screening.
In this experiment, I felt very happy. We can just relax, sit and relax, and even we can enjoy music while doing this experiment. Screening, it is observed that I had some abnormalities, and I had to go for the treatment also. Very right time I went for the treatment and I took the remedial measures.
Cancer Center did a clinical testing in our volunteers and patients. We have found that the sensitivity of the device is very high and it's more than 95%. Hence, we may be able to pick out early diseases at household level. And this will change the cancer scenario in India. We can go for the reverse flow ratio. That means more than 70% of patients now, when they 65 to 70% of patients, when they come with late disease, probably we can detect them early and save their lives.
Thank you all for watching this video. Myself, Aditi. You can ask me any queries about this product.
Hi, ma'am. Thanks for the presentation. So, any other entities other than Malabar Cancer Center has got this technology or has approached you for transferring this tech?
Yes, actually, one company has taken up this product by taking our technology from us. They are Murata Business Engineering India Limited, and they are now in their process.
Okay, thank you.
Thank you. One question from me is on the accuracy. Is 95% accuracy a good accuracy for such an instrument?
Actually, basically, sir, we got 100% sensitivity while comparing with the mammogram results. But instead, we kept it like more than 95%, that's all. By comparing the wearable device, adding up the prediction system and everything that I said about the more than 95%. It's when we compared with the mammogram results, all of the patients who had cancerous, we detected them.
Yeah, when you are saying all, I mean, how many patients were the clinical trials conducted on? What is kind of data that is coming out? Is it shared as well?
Not here. Actually, we did our clinical trials with more than 400 people, and there were around 150 patients, and other people were a healthy one. So we did a blind test, and from there we identified the persons who are having cancerous without looking their mammogram, and also the healthy ones were screened out by our system.
Okay, so then you are comparing it with the nanogram and then trying to look at that. Okay, thank you.
Since mammogram is the golden standard, we are comparing it with.
Thank you.
Thank you, sir.
Sir, I would like to add a few more points for your clarity. As I mentioned, in this process, if you were there at the initial speech I gave, director of Malabar Cancer Center who came over here, and that's how the entire thing started. And they did the field trial and for the patients as well as for the normal people over there for validation. That is one thing. The technology has already been given to, as mentioned by our colleagues, it has already been given to an MNC, which is trying to roll out throughout India. And they have done field trial various places across India. Northeast, they have covered already. Hyderabad, Akola at Maharashtra, various places this has been tried with known standards just to get further more data on selectivity, sensitivity, and whatever parameters that they need to be analyzed. They are definitely on the job and they were very happy and they have come back to us and they are now going to take the 3D analysis system also so that they will have the complete package with them.
Thank you, sir. Thank you for that explanation. But I am just still, if I understand it right, we are still not adopted any kind of FDA standards or similar kind of approaches. So some of these numbers matter, if I understand it right, and how many clinical trials may be of real interest for. Thank you.
Dr. Seema, would you like to add?
Yeah, this is Murugan here. I just wanted to select, for example, FDA, as we discussed. FDA basically for US because they have FDA standards. But for in India, we don't have specific standards exclusively for this kind of equipment. And moreover, the statistically important number of clinical trials will be a little more higher. That is what the technology takers are presently doing. They are getting a lot of data at various geographic locations, and they will be analyzing it for the getting there. They already have the NOC from the Director General of Health for commercializing this product. So they already have the NOC, so they will be going for that. But they are also having the statistically sufficient data. They are now collecting for that. I think my answer will be clear to you.
Thank you. Yeah.
Thank you so much. Are there any further questions?
Yeah, just a quick comment from my side, not more a question, but
please,
this that you're showing here, Dr. Raghu and Aarti and others, are quite commendable actually in terms of the innovation that you have developed and all. So beyond the commercial application for this particular, the breast cancer detection thing and anything like that, the same technology could be applied for, in terms of wearables. Wearables are coming out as a big opportunity right now, right? So across India and other places, and in terms of for heart rate detection or ambient temperature detection and etc. So this could be actually incorporated to that to create more commercial wide applications, right? Am I correct in my assumption?
You are 100% correct, sir. I would request Dr. Muralidharan, Dr. Seema, and Dr. Arul Kashmi to add on to this, please.
Yeah, actually, regarding this, we are also already working on different extending the same technology for different other areas also. For example, we are extending to some other cancers where we can detect it. So the works are going on, and also in the case of wearable devices, also this can be done. For example, if you want to monitor a patient's body temperature remotely from just like we had a pandemic here, we will not be able to go to the patient now. So we want to monitor. Those kind of works are already going on here. So it can be extended. That's what I wanted to add.
Sure, that's what I hope the audience would look at all these products and not only from the product that you're showing, but they will be inspired into create more and more commercial applications relating to this one, and they could connect with you, right? Connect with Cmet.
Absolutely, sir. That is the main purpose of this today's meeting, sir. We'll be glad to collaborate with anybody having certain specific requirements, how we can extend what we already know, or they can even propose absolutely a new thing. Okay, this is what I am doing. Can you help me?
Sure.
You don't know where from the spark will generate.
No, absolutely, Dr. Raghu, you absolutely said that, right? We have to work in a collaborative manner. So, unfortunately, I have to leave at 12, but just a quick question before going, right? So, for the benefit of others also, how do you actually help out with the technology licensing, be it in this products and others? If you can just quickly summarize that, it would
sir, patent is in the name of Cmet. Okay.
Right.
But based on a see, there is a process, like we seek expression of interest. Then a committee goes through whether they are technically competent to take up this, whether they are financially sound enough to roll out the product, all those things they go through. Once every green signal is given, headquarters does all these processes, and then it will be transferred on a non-exclusive basis based on agreement. You will get the license to produce it in India.
Okay.
And in that process also, if you require help, it is not that just we give it on as is various basis. Some of them may be at a TRL3, some of them may be at TRL5, some may be at 7. Whatever is the thing, we give it. And if you need to be further taken it up, for example, this wearable device, 2 years back we transferred, 2019 January. Okay. And the company is said that yes, you are validated with, as Ms. Arati was pointing out, around 200 plus 150. Okay, patients plus non-patient was tried. But they said that that validation is not enough. So they would like to have a lot of numbers, as mentioned by Dr. Muralidharan also. So they have taken up the technology from us, and they are doing the entire field test across.
Okay.
So they got enough data to confirm this. Then now they are again happy, and they are coming back for the 3D analysis system itself. So they get the complete picture. They also know where is the cancer tissue and what is its location. Everything is being now they are able to predict it. So that technology is also they are taking it up, and it will be floated across India to ensure that every woman is screened for this. So like that journey also, we are there with you people. So it is not that you took it at 3 and then we say bye-bye. No. But we have our own limitations also as human beings, as scientists. We have certain, so we may not be that thorough in commercialization or marketing. And so if you are clear that there is a market and clarity is there, we will be happy to handshake.
Well, thank you so much, Dr.
Thanks a lot, sir, for all the questions. Anybody else?
So adding to the previous question, there is a startup in India which captures the thermal distribution through thermal imaging cameras. So is there any difference in accuracy or the type of data collected on that one from this one? I mean, using sensors other than the thermal imaging cameras?
Team, please answer.
Yes, sir. Of course, there is a difference. It's totally different from a thermal camera. So as it's an wearable device integrated temperature sensors, you can wear it and your temperature data is measured, taking up your privacy. And coming to the accuracy, a thermal camera which is having high cost is only having a 0.025 degrees Celsius accuracy, but whereas our thermal sensors are having an accuracy of plus or minus 0.001 degrees Celsius. Here we are having the main differences.
Thank you, ma'am. Great. Thank you.
Are there any further questions? Salini madam, kindly go ahead.
Yes, sir. Thank you so much, Seema madam and team for the presentation. I think let's move to the next presentation by Dr. S.N. Poti, the transparent heater, transparent conducting lines, fiber optic probe for portable sensors, and portable biosensor with disposable chip. Also, I would like to tell the participants that you can directly get in touch with each of these innovators through our Rink portal. You can register and get in touch with all the innovators and the research institutions in Kerala. It's ring.startumission.in. We're looking forward to meet you all there as well. Poti sir, to you.
Good afternoon, madam. It is, I think, exactly 12 noon, so good afternoon. And straight away, I will share my presentation. So the first one is transparent heater. I hope it is visible, right?
Yes, sir.
Okay, so as I told, this is transparent heaters for a defrosting application. Actually, you can see one slide here. This is optically transparent. At the same time, it is a heater also. So this is we have developing Cmet a cost-effective technology, process technology for this kind of optically transparent glass films on glass sheets. So the idea is, or you can see a schematic diagram which shows there is a small square which is the glass plate, and both sides there is a electric connections are there, contacts are there, and if you apply heat through the both end of this, then definitely this will generate heat, and you can see one graph here. Now within 1 minute it can reach 60-70 degrees. So the major application is defrosting and de-icing, and the transparency is more than 90%, and a sheet resistance of nearly 100 ohms per square, and its coating is on a standard glass panel, and the technology readiness level is around 4. So this is a cost-effective coating. There are some materials available, but this is a simple oxide material with which, and the coating technology is a spray kind of coating, so that you can actually enhance to any, or you can actually coat on any size substrates on. So there are two, even in the circular shape or in another in a square shape, and I will show you one demo. This is actually showing the defrosting action. Of this film. See, we have applied 12 volt at the 2 contact leads on opposite sides, and you can see that within a fraction of minute, everything will go from the glass slide, so that it can be used as a transparent heater for defrosting applications. And this is actually we have applied for patent. And what is the present situation? Actually, maybe you can see array of film heaters are available in the market, but this array of film heaters for industrial and residential sectors for heating surfaces, floors, and walls, and this consists of a substrate printed or coated with reference with the resistance material, and there will be an electric contact, generally opaque. So it is not at all suitable where transparency is essential. This is actually the innovation solves it's a simple and cost-effective process technology, and provides optimum coating for excellent heating performance with good optical transmission. And where it will find applications? It is in automobiles, and you can see that there are metallic lines on the rear side window. So you can always replace that, but it's not only in the rear window, but on all windows it can be replaced. And in supermarkets, to keep to maintain the transparency of the glass top, you can coat this optically transparent film, and you have to apply a small electric volt for heating it. And in cold regions, you can actually coat this on in the glass shelves kept at the shops, in restaurants and small shops. Then food items can be kept at safe temperature until service. So this find applications in these areas, and several areas where optical transparency is required at the same time. You want to take it maybe 50 degree or 60 degree or even 100 degree. So it is, as I told, no company, no industries are making such cost-effective coatings for making transparent heaters. And this technology uses vacuum feed technique, which makes the product more economic. That's all about the first product, transparent heaters. So, any questions?
Dr. Poti, sorry, I was not there for a few minutes.
Okay.
So whether you showed that video where you could show
Yes,
that?
yes, I was shown, sir. I was shown.
Thank you. Thank you.
So maybe I can show the next. Okay.
Somebody has raised the hand. Salini, madam.
Mr. Abhilash, I would like to ask.
Yeah, Abhilash here. So, I mean, in fact, when we are saying it is required by say, it is a requirement from automobiles as well, and different. But what is the kind of consideration there is different, right? So we might need to make adaptations, or is it more like this is a generic substance that can be used across, and you can make variations to it, or how is it conceived?
Sir, the material has been developed. The feasible applications is what we have in mind. We have just highlighted. And for a specific application, we would definitely need to know what are the other aspects that need to be taken care when we want to put it on an automobile, or when we want to put it on a food containing storage device. Dr. Poti, did I answer correctly, or you would like to correct?
Actually, sir, in a car, in a vehicle, no, the minimum thing is that it will provide only 12 volt. But for de-icing and defrosting, actually, we need to take up to 30-35 degree. So in a bigger area also, we can actually do this, no, within this 12 voltage. So depending upon that, no, if the temperature you are actually looking at is very high sometimes, and the size of the glass panel you would like to coat, these are all actually depending upon the energy we have to give for heating.
Thank you. Thank you very much.
Thank you, sir. Actually, it's so nice that you're asking many questions. Can I ask you one question, if you don't mind?
Please.
Can you please tell me, like, from which industry you are representing, or which institution, kindly?
I am basically from Thai, so I work with. I have worked with say industrial automation like ABB, and currently working in an educational technology enterprise. But then, yeah, I'm basically looking at, I mean, how we are kind of transferring technologies and kind of thinking at how we can support the course.
Yes, sir. You are most welcome to contact us. We'll be happy to help you out. And adding one small point, since you mentioned the word tile, those are all coming under traditional ceramics. And as I mentioned right at the beginning, our many of activities are electronic ceramic materials only. So in fact, way back in 90s, early 90s, at that time, our Dr. Sashidharan was there as director. And for one of the tile industry came to us from Trishur, and they wanted a glaze coating colorant, okay, with various colors over there. And I think that technology has been developed along with them. So such kind of things are also feasible for traditional ceramics as well. So if there are any requirements that we can help the tile industries or any other ceramic based industries anywhere, we will like to see how best our knowledge on electronic ceramics can be applied to other areas as well, sir. Thank you.
Thank you.
Any other questions?
Professor, Mr. Abhilash is from Thai Kerala, which is also our industry partner. They are a global community which supports the entrepreneurs across the world. So he is from Thai Kerala.
Thank you, madam. Thank you so much. Any other questions?
So I think we can continue with the presentation.
Yes.
Okay. So the next product is also a related product, but here this is a transparent conducting lines, at the same time optically transparent. The other one is a heater. Here you can have invisible lines on glass as well as on flexible sheets. So this is a low resistance electrical lines on glass or flexible sheets, and LEDs at one end of the glass. or the flexible sheet can be powered by applying electric power on the other end. So this is also a simple process and no blocking of light. Ideal solution for invisible electric contacts on transparent glass, and the sheet resistance is just 60 ohm per square. So this video will actually give an idea about the transparent conducting lines. A battery is connected at the end of two glass sheets coated with transparent coating lines, and see, you can see the LED is glowing and it can be connected at any place. So you will not see the electrical lines passing through the glass. And it's a flexible transparent sheet. There also this kind of coatings are there. A battery voltage is used, just the LED is glowing there. So the innovation here is, or the issue is, the transparent coatings for electric line contacts are why it is required. See, for carrying even a small power, we need metallic lines. So it is not at all suitable where transparency is essential. So the innovation solves the transparency is more than 90%. And this open up a route for fancy lighting applications. At present tested up to 5-inch length glass piece. And the technology is actually now available on flexible sheets also. And uses where transparency is needed in electronics, along with the thermochromic coatings on glass panel. And as I told, for fancy lighting applications. And of course, there are other, if there are some other customized applications, definitely you can use these transparent coatings. And the existing competition means commercial scale coating facilities for transparent electrical contacts are not available to the best of my knowledge. And the simple coating, this is a simple coating technology and can be extended to larger dimensions. That's all about the transparent conducting lines. Any suggestions or any further comments?
Sorry, sir. So I was just saying we have two more products, fiber optic probe for portable sensors and portable biosensor. Can we present that and take the questions together? Because
no, because these two, whatever actually I presented, the first and second are in one category and the other two in another category.
Okay.
Madam, we understand the time constraints. Sorry that we are exceeding. We'll wind it up. One small comment is that these are all possible applications we are projecting. Probably, I feel this has a lot of implications in security angle also. So, if there are anybody is interested in that kind of transparent and you can't see that, maybe having a lot of implications there. Kindly look at it. Okay, kindly go ahead.
Yeah, I will move to the next one. This is fiber optic probe. Something happened?
Sir, you have stopped sharing the screen. Now it started again, but it is yet to be visible.
Once again, I will do that. Sorry.
In the meantime, I'm not sure whether this was answered. In the chat box, I'm able to see really a commendable innovations. Okay, we will come to that later. Team, kindly look at the chat box also. That is on thermal sensor. Okay, kindly continue.
Now it is visible, right?
Yes.
Yes, sir.
Okay. So this is actually a fiber optic probe. So this is slightly different from the previous one. The fiber optic probe means this is a usual optical fiber, but optical fibers can be used for several other applications. But if you construct one sensor with optical fiber, definitely it can be used for remote sensing. And if it is this is very small. The fibers are very small and can be used for miniaturized devices. And as you know, no electrical powers is required in so that the data can be transferred effectively using optical lines. And another advantage is that many sensors can be multiplexed along with the length of the fiber, and it is immune to any electromagnetic interferences. And it's actually many of them are based on glass and will withstand high temperature. So this fiber optic probe, you can see the enlarged portion here. This is actually where we are coating the this portion is our sensing area. So the apart from this fiber optic probe, the sensing system consists of a light source, a sensing portion like this, and a readout unit. And we have already validated this for ammonia sensing as well as for hydrogen sensing. And our innovation is the material. Cmet's innovation is a cost-effective sensing material, that also by engineering material properties. And this is, of course, an environmental friendly material. And our approach in this work is the material which we develop is caught on the optical fiber for portable sensing applications. And it's a plasmonic approach, not a resistivity approach. It's a plasmonic, an optical approach. And definitely, if you have to add some affinity material for a specific gas detection, then only that particular approach, the specificity will come into picture. So the first, our material will be coated on the optical fiber, then an affinity material. If it is ammonia, there is a polymer material. If it is hydrogen, there is another affinity material. So that also we have to actually coat over the material. So the technology feature is like this. We have actually used 400 and 600 micron optical fiber cable. And these are all disposable type probes with a 12 centimeter, or you can actually reduce this to as per your requirement for detection. And a small core diameter allows very small quantity of the sensing sample. And plasmonics technology is actually known for accuracy, efficiency, high sensitivity, and selectivity. And as I told, this can be used for online monitoring and remote sensing. And they can be engineered for any gas, though we demonstrated initially for ammonia and hydrogen gases. And in the demo, I will just show one demo. In that, this is a general demo for gas sensing application. So this is the probe. This is mounted on a platform, and the bottle having a gas. We are just opening that gas, so that it will immediately reach the optical fiber, and you can see the real time. This is a real time analysis. Plasmonics technique is always used for real time analysis, but here the innovation is that we have actually used this actually this is now this work is going on. It is converting to a wall mounting sensor, so that the size will be very small with the optical sensing probe for gas detection. And the conventional fiber optic plasmonic sensors are using the expensive noble metals, gold and silver, because there are these materials are typically exhibiting plasmonic properties, and since it is gold and silver, it is not at all economical, and it is not disposable type, and therefore no portable device. And this innovation will solve the problem or the novelty of Cmet technology is that it's a simple coating technology on optical fiber, and definitely this can be used as a disposable one. And when I say about disposable, it is a green technology, just a simple coating with earth abundant metals. And since it is optical fiber, it is ideal for remote sensing application. And the applications, as I told, suitable for wall mounting type gas sensor applications, and can be extended to any gases, and can be explored for point of care device applications. And no industries are making cost effective optical fibers for gas detection, and this uses low cost coatings of cheap fibers, which makes the product economic. So this is all about the fiber optic probe we developed, and currently actually developed or demonstrated for gas sensors, but it can be used for any bacteria or any virus or any other thing by suitably functionalizing the optical fiber. So that is all about this fiber optic probe.
Any questions?
Sir, there is a question on the chat. Can you detect carbon monoxide, carbon dioxide, formaldehyde, and other VOCs?
Yeah, actually, as I told, always there should be an affinity layer. With that affinity layer, this is being extended to NOx also. So any gas can be detected, but by suitably selecting one affinity layer. That's not a difficult thing. But the sensing is already demonstrated. Ammonia with the 10 ppm level, and hydrogen with the 25 ppm level.
Hello. Hello, this is Srini from IC First. Can I put a question? Yeah.
Please.
Yeah. Is there a possibility of using such sensors for dissolved oxygen in water?
If there is a requirement like that, definitely we can think in that direction. But so far we have demonstrated this for gases, but liquid ammonia.
Yeah, generally there is a huge.
Pardon? No, we have actually tested.
Sir, your voice is. Can you repeat your question? I think connectivity lost. Probably. Can you put it in the chat box, sir? Any other questions?
Yeah, this is Rink, panelist. You mentioned about detecting virus and bacteria. What concentrations can detect?
No. Actually, I will come to the next presentation where actually we developed a bacteria sensor. There is a possibility we can actually go into that direction using this technology.
What about formaldehyde and VOCs?
That is what actually right now we have demonstrated with aqueous ammonia, gaseous ammonia, and hydrogen, and with a suitable affinity layer, definitely we can extend to any gases or any liquids.
Okay. What would be the probability developing something for VOCs?
Sir, actually, definitely, we can think in that direction. And the only thing is that, no, the sensing action, sensor is ready, and it has to be extended to the particular thing. Definitely, we can look into that aspect, no doubt.
Okay, thanks.
Somebody has asked about H2S.
Even H2S, see, the question is that right now we have done it, and even in NOx gas also we have actually started, but H2S also I think possible, because the selectivity issue is the main thing in sensors, and if, as I am repeatedly telling, if there is a proper affinity layer, then see, this must have actually proved for with the resistivity sensors and all. There will also be they must have used an affinity layer. The same affinity level can be used for optical thing also. So definitely these kind of things, even crude leakage, these are all the success of this are all dependent on the layer. There should be lock and key mechanism. If that kind of a material is there, then definitely we can extend to any material.
What would be a lifetime for this?
In two way I can tell this. Actually, the fibers, optical fibers, we know these are all standard optical fibers, and the coatings are simple oxides. So these are all not at all affected by any environmental things. But second thing is that it is so cheap that it can be used as a disposable type also. So we are actually using kilometers for this kind of optical fiber. And if you actually take hello, and if you
I cannot avoid. I'll try.
You are actually taking some 10 centimeter or even 5 centimeter will also work. So in both ways, this is stable. At the same time, you can use it as a disposable thing also.
Okay. Any further questions? If not, Dr. Poti, kindly go ahead.
Yeah, I will.
So one more person has raised the hand.
Okay.
So would you like to ask? I have given the talking permission.
Chemtel.
Yes, I have a question. I'm from Chemtel, and I would like to know if, in case your innovation can detect the leakage, especially, I'll give you a scenario in 1 minute. What happens is that the crude which comes out of the refineries, it has to be after the refining is over, it goes to the various vessels for carrying it over, and there is a leakage as such, which is not detected as such. If you can, is your technology can be amended or added, or can add some value addition to such a leakage to understand, maybe remotely? I have a project, frankly speaking, I have a ready project with me for a very large company internationally.
Okay.
And I'm looking forward to some such a thing. And second question is, of course, if I don't know, you have answered it, but that doesn't get me to regarding the H2S leakage. Now, H2S leakage is much more prevalent in the refineries. And my question relates to that only. Both the questions relate to the same type of domain, I would say.
I think, no, we have actually come up with the ammonia sensing that is also a corrosive thing. Similarly, just we have to work on the other gases. Then only I can answer it properly, because selectivity is the main issue, no?
Mm-hmm. Tell me one more thing before you answer any question. If I give you a project, how much time does it take for you to do that?
No, the thing is that actually, normally, if you our director will answer, but this technology is ready now with us. So the coating is ready, the fiber optic probe is ready. Now the question is only extending to a gas.
Okay, and how much time did it take for you to make this innovation?
This is actually, see, the H2S means first I have to have a feasibility thing. No, H2S,
No, I'm asking about not H2S, the ammonia and hydrogen which you have already developed.
Yes.
How much time did it take for you to develop this innovation?
No, these are all actually through funded projects, no?
No, time. I'm asking about time, not the funding. Timing.
Maybe.
Sir, I would say that basically first he developed the heater material, then he moved on to the sensors. Then from there he moved on to different applications. And one of that is ammonia sensing, which was done for Department of Atomic Energy, and that has been funded by them. But it will see obviously initially the growth will be slower pace, but now we can obviously we can jack it up, because we are now confident that we know the sensor material, how it works and all, but we need to definitely understand how, as Dr. Poti was mentioning, how your specific gas is going to interact and what sort of engineering
No. I will
material part of it. It will take us minimum 1 year.
Too long a time, frankly speaking. In such a scenario,
we can work it out, sir. We can see whether it can be shortened depending on the requirement. Nothing can happen overnight. Kindly, you need to understand that also, probably. Okay, am I answered correctly or
correct, sir? Because this kind of coatings, no, we reached the stage by stage by engineering the material property, and now we are replacing the expensive gold and silver with the simple things. So
Dr. Poti, this is Riaz from Startup Mission. The question was related. It's related to how, from an industrialist, related
I know,
to
I understood.
the time is very, very critical. So just think about it, and we'll let us see that. Okay.
Sir, we assure you that we will definitely put all our effort to make it as per your requirement, but kindly understand our limitations as well, so that the things go smooth for both sides.
I would like to add here. When you're working in an international scenario, you cannot say that you have limitations. In that case, one has to be very, very quick to answer. I mean, for instance, I'll give you an idea. This is a product probably your company or your organization can undergo and take it because you have already undertaken similar product. But to understand that this idea goes into mind, and the answer to that in your mind is instant. It has to be, yes, we can do it. Yes, we cannot do it. So in that case, one has to be very, very quick to take, okay, this is the area that comes into our domain, and we can answer that question. We can do that. If you cannot, then probably one has to go somewhere else. And talking about the time,
Sir, I will tell, sir. I will tell one
incident. Changing every day. We are changing every day. And frankly speaking, I'm into the international business, and when I'm in the in innovation, then if the innovation is not directly connected to the time, directly proportional to the time, you cannot help it. This is a pure mathematics. So in that case, it takes 1 year time for a new innovation to do that exercise. Long time.
Actually, see, in the next presentation, I will tell that one startup from Trivandrum, he is also contributing to that innovation, so that within 6-7 months, I told the first proof of concept we can complete. Because
when Dr. Poti, I wanted to know from you, when I gave you an idea that can you detect a H2S leakage? That means gas leakage you have already interacted, right? And this is again a gas. And if the thinking in your mind and this thinking in your mind is striking that yes, it can be done, you could have you can tell me how much time would it approximately take. Maybe 2 years, maybe 1 year, maybe 6 months or something like this. But if it is not connected to your mind, then probably answering any question such the timing has got nothing to do with that. Does it connect to your mind, Dr. Poti? Do you think that H2S detection is possible?
H2S detection is possible, but at the same time, I told initially, I have to find out a proper affinity layer for the proper selectivity.
But that is all these property levels are all published. Well, you can always have it.
Yeah. See, offhand I cannot tell that. No, that is the only thing, because we have worked with several gases now and working with NOx and all. So you are telling H2S. Definitely, I will attend to that, and I can come back to you also.
I'll tell you, Dr. Potti, one thing. If you can do that exercise of detecting H2S, I tell you, you are sitting on a very, very large business. You cannot imagine. Because till this time, no international company is in a position to detect HTS online, on the spot. But if you have already done some exercise on ammonia, you have done some exercise on hydrogen, then you are sitting at an idea which probably can explode whatever you want. I mean, then I'm asking you will be yours, because nobody could do it. But and that's possible only in case you can do it. So this is an idea. I thought I'll give it to you, and let's see.
Thank you.
Thank you so much, and we will definitely welcome such ideas, and we will definitely see how best we can work together, sir. You kindly contact us. We will try to see what best we can do.
No, you have to contact me. I need not have to contact you. I have an idea, given it to you, and if you want,
I do, sir. Anyway, if you come through the this platform which has been created by Rink, definitely we will contact you, sir.
Sure.
Because we need to know your ID and your how to contact you, those basic details. Kindly provide us. Right?
See, I am in the international.
Understood, sir. Kindly give your contact, email ID
You listen to me. See, in the international business, when somebody is already there, he can give you a value addition in thoughts, right? So that whatever you are doing, you can add value to that. And compromising on that thoughts and giving in words has got no meaning, which you are giving to me, that you will think it over, you will come back to me and all this thing. Because you are interested, call over. Simple.
Fine, sir. Thank you so much, and we appreciate your open remarks. We are for it.
Look forward.
Salini, madam, can you make my video so that I'll be able to switch it on and off? Anyway, kindly go ahead, Dr. Potti.
Thank you, sir. Sir, your name, please, sir?
Raghu.
No, sir. The gentleman from Chemtel.
Yes, you can call me Chemtel.
Okay, so we'll connect you both after this presentation.
Sure. Look forward to.
Thank you, sir.
And we support the startups, and in case there is something else, we will support not only financially, not only mentally, but of course by giving them the inputs which is required in the technical inputs which is required. We are very well. We are quite good at physics and mathematics, so that we can do it ourselves. I mean, we can help people to connect and generate their add value to their own thoughts.
Thank you so much.
Thank you so much, sir. We will be happy to interact with you.
Yeah. Look forward.
Thank you.
Thank you. So this is the last presentation from my end and the Cmet side. So this is again a plasmonic based technology, portable biosensor. And this is again cost effective. I will explain why I am frequently or repeatedly telling cost effective. It's that I will come in one of the slides, and it is cost effective process technology for sensing biomolecular interactions. For example, any antibody antigen, protein or nucleic acid, etc. And this is in the picture. It is a basic unit for validation. This also uses, in addition to this, a light source and a sensing portion and a readout. And this is suitable for portable point-of-care sensors. And again, the innovation is actually a film, a sensing film. This also did actually step by step and reached this stage by properly engineering the material properties. And this is through a simple and scalable approach, and with a consistent performance. And in the picture you are seeing 1-in chip. This is also a green technology, can be recycled, and this particular thing can be functionalized with the biomolecules or ligands effectively for any sensing purpose. And this definitely open up a new area, possibility of several portable device using this our material. And the technology is, as I told, in 1 inch by 1 inch or even less than that is now we are trying with one institute for portable sensing application. And the approach is a novel approach in the already proven plasmonic technology. And the functionalization strategies already tested on this material, simple approaches, and definitely this is tested and validated at biotechnology centers. It is not a biotechnology center. And the performance is accurate, efficient, and the high sensitivity, selectivity, and the scope suitable for portable point of care device application, and ideal for out of lab environments. And this small video, this is actually this particular sensor developed jointly with Rajiv on the Center for Biotechnology. They have done the functionalization on our material. This is for foodborne bacteria. So I am just showing the overall idea only here. We are just mounting the sample on the small device we fabricated. And then we are actually applying the flowing sending the solution, and it exactly wet the functionalized film. So you can see that immediately it can actually identify. So in this we have already done tested Salmonella, Shigella, E. coli, etc. And maybe 3-4 bacteria we tried at Rajiv Gandhi Center for Biotechnology. And the final device is actually under progress. And this will be a cute portable device. With this, any bacteria can be tested, but it's not bacteria specific. General bacteria for general bacteria detection, and the colony forming unit, if we tell, in the Salmonella has been detected with a 200 CFU per milliliter, and E. coli also nearly 300 to 400, and Shigella around 500 CFU per milliliter. So that way we tested and validated this server at Rajiv Gandhi Center for Biotechnology. And the cost effectiveness, again I am telling, the plasmonic things are all developed, so far developed are all with gold layers or silver layers. So it cannot be used as a disposable chip, and it cannot be a portable device, because every time you cannot recycle or you cannot clean the chip. So the one which we now fabricated is with a simple oxide coatings and can be used as a disposable chip, and it is very suitable for ideal for community level testing. So definitely this kind of sensors will be a portable and a point of care device for health workers. For those are not at all maybe medical, other than the medical people, they can also just simply test the bacteria in anywhere, in restaurants, hotels, or anywhere. And the existing thing is that the portable device for detecting foodborne pathogens are not available with our maybe the health department or any other people. And since it is low cost for detection, definitely the product will be economic. And other initiative currently going on is a nucleic acid based biosensor for biomarker detection with the Malabar Cancer Center. Proof of concept is almost completed. And as I told initially, a startup is also actually contacting us. He is also telling that we cannot wait for more, and immediately agreed, because 50% work is from him, the biotechnology part, and definitely it can be developed within 6 to 8 months. That agreement is also now between going out with these two, with the startup and Cmet. And definitely no other novel portable devices for several societal applications. We are joining hands with different people, different institutions, and even many others. And why the association with the startups or industries? Definitely, I can think of potential sensors. If I can design and develop potential sensors, if some startup is coming with a unique idea, like SAR is telling one H2S thing, so such way we can design and develop sensors for that. And definitely it will decrease the time to move potential sensors to market if there is a linkage between startup and industries. And definitely the product will reach the market at the right time, so that the benefit will be to society. And both entities, Cmet and the startup or industry, knows to sustain growth in their areas. So that is the one which we are looking at this stage. And definitely for this work, I have to thank my team members: Pakisalam, Sumesh, Sajid, Sridevi, Vishnu, Dr. Prabhesh, Vaishak, Saumya, Leah, Tony, and of course our parent ministry, our institute director. Thank you very much. So questions from this last portion.
I have one question. You mentioned about this CFU in the food. Can you extend this technology to gas detection to determine the amount of bacteria or virus in the air?
Yes, sir. Actually, now it is extended to bacteria, and definitely possible to any this kind of communicable diseases and all. No issue. We can actually, the only thing is that Cmet is not a biotechnology institute. So if somebody is actually contributing that side, the antibody, antigen, or a protein, that's why we are collaborating with the Malabar Cancer Center. We are collaborating with the Rajiv Gandhi Center for Biotechnology. So such institute, one material science institute and one biotechnology institute. Definitely some new products will come in this area.
Is continuous use possible, or is it you have to change the chip all the time?
No, same chip, but functionalization is different.
Okay.
Yeah, hi. This is again Srini from ICFOS. The question is again related to water quality testing. Does it sound, is it actually a faster water quality testing method compared to the traditional ones, which take a lot of time for E. coli detection and other things?
Sir, E. coli real-time analysis, we have done that. That's why even the Rajiv Gandhi Center for Technology, when we took our setup to Rajiv Gandhi Center for Biotechnology and they functionalized, all others were also told, within a fraction of a second we are analyzing E. coli. So the technique is very good for real-time analysis. E. coli we have tested and verified.
Okay, I think that will be very helpful, because especially in water quality testing and management, your product is going to be very helpful. We will be in touch with you.
Thank you.
And Dr. Poti, is this possible to get this E. coli, etc.? I mean, to find out E. coli in the urines, etc. Also, when you talk about the detection of E. coli?
Right now, sir, possible, sir. Why? Because E. coli, the key and lock mechanism is for E. coli, no? So it is possible.
Yeah, it's possible. Okay, because in that case, if it is that it will give a lot of help to the technician in the laboratories who does this human antigen or bacteria detection, etc. and all that. I think it would be good. And how about is this particular instrument is waterproof or can be made waterproof?
Actually, sir, this is in this. I told there will be a light source, there will be a detector, and at the same time we have to feed this solution exactly on the functionalized chip. So these are all actually we are now developing that. I told within this, by the end of this year it will come a leak-proof thing. Exactly, the solution will actually touch only on the glass sample, and the other the microfluidic path is there. So the other way it will come out.
Fantastic.
So it is a hand maybe standalone equipment at the time. One can, it's a portable, but I told, this way it works.
Fantastic. I think this would be a very good help to the technicians in the laboratories. Thank you so much.
Thank you, sir. And kindly you can contact us through Rink also. Thank you, sir.
So we have a question at the Q&A. What are the major applications of the bacteria detection instrument developed in collaboration with RGCB in a healthcare institution?
What are the major applications of bacteria detection instrument developed in? Actually, see, the particular project what we initiated is to detect the foodborne bacteria, that is for health workers. And in a healthcare institution, even the bacteria detection is important, right?
No, Dr. Potti, allow me to speak a little bit and answer on your behalf to this gentleman.
Okay,
see,
very good, sir. Thank you.
In any infection, there are three things which are important. One has to see as a technician or as a laboratory person or as a doctor. One is whether it is because of virus. Second, either is because of bacteria, or third is it because of fungus. There's no fourth one available, right, in this world. So if you're talking about bacteria, then bacteria could be, it could be in the animals, right? This device can be used in the function of finding out the bacteria in the animals, in the humans, and of course, as Dr. Potti says, if I'm not wrong, in the food materials also, right? So in that case, all these entire spectrum, I would say, entire canvas of bacteria can be detected. If I'm not wrong, Dr. Potti, am I right? Can be taken care of that. So when you talk about the healthcare, it could be the urine test, it could be the theoretical test, it could be the I don't know about the blood, etc. But I think if they have already done that exercise, the other areas they can do also, because there's in the chain there is not much of a difference. Am I right, Dr. Bhatti?
Correct, sir. Because this is essentially a lock and key mechanism. So the functionalization we have to do in a proper way. Then definitely the selectivity will come. Blood also we have planned.
So, Dr. Potti, I think you will be adding me into your institution as a consultant, right? And I'll get some money from you, right? No, it's a joke part. Thank you so much for
Thank you, sir. Thank you.
For giving me the opportunity to explain on your behalf. Look forward. Yeah.
Thank you for answering on our behalf, sir.
No. It's because Dr. Potti was finding a little difficult from his face.
Because we are basically from materials background.
Materials background, sir. That is the issue.
No, you see, as long as you understand mathematics, then you can talk on any subject related to science, because mathematics is the mother of all the sciences. Anything related to physics, anything related to chemistry, biochemistry, you name any other thing, the umbrella is under the mathematics. So that is why I thought that allow me to give some inputs on behalf of Dr. Potti. And thank you so much for allowing me.
Thank you, sir.
Thank you, sir. Thank you.
Dr. Potti, one
Darling,
question.
madam. Yeah. Anybody? I will go on.
I have one question regarding, you mentioned about lock and key mechanism.
Yeah.
Does it mean that it's only one-time use and then throw away and put a new sensor?
Actually, in the demo we have done in that way only. But definitely we are actually splitting into several things and keeping so many compartments in a slide. That way now we are planning so that it can be used, because only once you use, then again if you use in the same thing, it is difficult. But we can enhance the maximum number of places where one slide can be used for analysis. Even another SPRI imaging is there, that with the Digital University we are planning 50 together, 50 analysis together.
Thank you.
Only, madam, kindly go ahead. in chat box, somebody has written, Salini madam.
Yes, sir. We will be having these recordings in YouTube. So we'll share with all the participants as well. Also, I would like to invite Riya sir to share his thoughts. Sir.
Good afternoon. It was nice to listen to all this great discussion and the innovations. Basically, I was just going back when we designed this research innovation network. We initially thought we just create a technology platform and just open up to the research institution as well as with the business community. Then soon we realized that that is not sufficient. We may need to act as a proactive catalyst so that we can bring together stakeholders from different groups, both from the academic or the research fraternity as well as from the industry front itself. So this today, when we host our fourth demo day as part of the Research Innovation Network, we can clearly see the evolution of this project itself. We primarily Startup Mission we primarily intend to accelerate the pace of technology innovation and the technology commercialization of the research product from our research institution, not only from Kerala, from also from the outside the state also. And we came up with a couple of schemes as well. Those who take up this product from the research institution, we do extend support through multiple intervention, either through the grant schemes or through a venture capital support, or even we are right now working with an international agencies to design a research incubation program exclusively for the researchers as well as the innovators who wanted to build business around the innovation. I think that would be the next step in this this whole project itself. Also, last time we had announced a research innovation challenge. Because of some other procedural issues, we couldn't launch it. And we are going to launch this exclusive innovation challenge among the researchers across the country. And that will be launched at the end of the October itself. I think today's presentation from the Cmet also was really nice, and there are a lot of discussion happened. I'm pretty confident that when the passionate researchers meet and work with a passionate businessman, a new set of innovative business will emerge, and we do look forward to that direction itself. And we will get back to you, all the participants, not only from the researchers as well as with the business community. And because of the COVID scenario, we were not able to facilitate some of the projects activities we planned as part of this project. So probably since the COVID situation is restrictions are taken, so we may initiate a small business roundtable with the research institution in the coming days itself. I think this is a good beginning. Let us continue work together. Thank you.
Thank you, sir. So thank you so much. Thank you, Riya sir, Project Director Kerala Startup Mission, for sharing the Research Innovation Challenge and about the roundtable which will be coming up. And that was a wonderful 3-hour discussion today. Thank you everyone for being part of Rink Demo Day. As you know, Rink primarily tries to bridge the gap between translational research and entrepreneurship. Thank you, Cmet, for hosting the September month Demo Day. Special thanks to Raghu sir and Koti sir, and sincere thanks to Stanley sir, Seema ma'am, and the entire Cmet team. It gives us immense pleasure to acknowledge the presence of Ajayan sir, Managing Partner of Vritti Consulting and Training Services, the presence and interaction of Nizam sir, the CEO of Maker Village, interaction by Mr. Abhilash Gopalakrishnan from TAI Kerala, Mr. Srinivasan Ravindran from International Center for Free and Open Source Software, ICFOS, Mr. Siriek Palakil, one of our active participant of Ring Demo Day, Mr. Umar Salim, and the gentleman from Chemtel. Who can be part of Rink? Anybody who is considering the possibility of collaborating with a research institute or creating your own venture with a societal impact, or to create businesses around cutting edge technology can be part of Rink. So Rink gives the opportunity to experience and get connected with the potential collaborators. A lot of our doubts today were to get connect with the innovators and the research institutions. We have a technology platform developed in association with CDAC to bring together all the stakeholders in a common platform. This would enable you to explore opportunities available in the entrepreneurship space and take up your innovations to the marketplace. Also, this acts as a collaboration platform for collaboration, and any R&D institution, entrepreneur, mentor, corporate, investor, research scholar can be part of the platform. We welcome you all to join ring.startupmission.in and get connected with the stakeholders and find what's best for you. So you can also write to us at ring@startupmission.in in case of anything related. So finally, on behalf of the entire Kerala Startup Mission team, Thai Kerala and Cmet, I sincerely thank and acknowledge every one of you. Thank you for attending the session and actively engaging in the discussion and making this demo day meaningful. So let's be in touch and inviting you to join the next session on October 28th with KTU, APJ Abdul Kalam Technology University, partnered with GTech Academia and Technology Focus Group. Until then, stay safe and stay connected. Thank you so much.
Thank you, madam. Thank you, Dr. Riaz. It was wonderful. Thank you so much for providing the platform. Thank you all participants.
Thank you.